Okay, another rational function where we're supposed to find the asymptotes, and in addition to that, get the graph. So let's find kind of all of our key features here first. First, I'm going to, let's see, horizontal, you look again at the degree on top, degree on the bottom. So we'd have like the 5x over the x squared. If you reduce that, so to speak, you'd have an x on the bottom that's going to infinity for horizontal asymptotes because you go out to the right and to the left forever. So anything over an infinity, that's 0. And since this is y equals, so my horizontal asymptote here would be right on top of the x-axis. The vertical asymptote, also you need to consider if you can cancel or simplify this. I don't see anything that's going to factor to cancel. The denominator would be x minus 3 and x plus 3, and that's where we look for our vertical asymptotes. So my vertical asymptotes here, when does x minus 3 equal 0? At positive 3. So we've got a vertical asymptote there. And where does x plus 3? X can't be negative 3, or we'd be dividing by 0 there. So that gives our horizontal vertical asymptotes. When do we have an x-intercept? When does the numerator equal 0? So 5x equals 0. This would be for the x-intercept. And so if I look at that, that's at 0. So I'm in here. As I get over here, say closer to this point, if I put a 2 in, where am I at for that? It would be my question there. So if I put in a 2, 5 times 2 would be 10, and 2 squared is 4, minus 9 would be negative 5, so it'd be down at negative 2. At 2, I'm down at negative 2, so that's like over here. So since it's an asymptote, I know that that part of the graph's going over there. If I put in a negative 2 would be negative 10. And then if I put a negative 2 squared, that's 4, that would be negative 5. So that would be at positive 2. When x was negative 2, that would be positive 2. So that's over here. So then it's must be doing this in that section. Now we still have to go on each of the other two sides to figure out where the graphs are. So let's say we took a look over here past the 3 at 4 or 5 or 6 or whatever. So if we go over there to 4, when x is 4, that would be to the right of this line, right? Over here somewhere above or below 0. Put in a 4. 5 times 4 is 20. 4 squared is 16. 16 minus 9 is 7, but that's positive, right? So over in here, I'm up in that section over there. Well, and then the same thing. We got to figure out what we're doing over here on this far left. So if I go to the left, let's say x is negative 4. And you put that in. 5 times negative 4. 5 times the negative 4 would be negative 20. And then negative 4 squared is 16. So that would be a negative number. So then that means over here, it's down in that section. And then, you know, just one more time. That's how you find all of the key features. But if we also just want to do a quick little double check again, 5x over x squared minus 9. Let's just see if that looks right for what we come up with. Let me share Desmos with you again. And I had a 5x here. And x squared. Shift 6 for the caret squared. Change that to a minus and put this in as a 9. Whoops, I lost my fraction there somehow. Uh-oh. I need all of this. X squared minus 9. I want all of that down here. 5x over x squared minus 9. And That would appear to me to be, there's my 3, there's my -3 vertical asymptotes. Horizontal asymptotes. Now notice I've had students before, my horizontal asymptote out here, the graph is approaching 0. That's good, the x-axis over here. But in this middle section, it actually crosses it. So it doesn't have to approach everywhere. And it doesn't mean it can't cross it somewhere. It just means there is some place where it does approach the graph at that point. So those are all the parts of how I would find the graph. And then on this one, choose the correct asymptotes below. So verticals are x equals, because the x is always that constant number. So x equals 3 and -3 were verticals, and y equals was 0. So I don't know what these 5s are. It would be D here. +3, -3 for the verticals, and then where we analyze this, where it was x left in the denominator going to infinity, so that'd be 0 for the y horizontal asymptote. So more rational equation functions and coming up with their graphs.